Oh, hello. Welcome to this channel. Today we're going to explore very long questions. So we got three small questions in one area on the curve question. Before starting the solution, just remind everyone, if you haven't subscribed this channel, it's time to do so now. So you can take advantage of accessing all those 149 videos. So this is 149th videos and nearly 150 now. So that's a great result. So if you can remind yourself, just click at the button, the little bell button. That's all you need to do. All right, let's do today. We're going to start doing the question here. We got a function here. It's a log. The function is log at 1 plus x squared. So this is a curve. So we need to prove the fx is a concave up. So it means we need to prove that okay, how do we prove? So we need to find that so let's do first derivative. So when you do concave up, you must try to prove the second derivative is positive. So let's do the first derivative. So first derivative, that's the answer will be make x first derivative equal to 0. So the answer is x equal to 0. So then I'll do the second derivative. So when you can see the second derivative using quotient rule, so we will get, that's the answer for the second derivative. So we substitute 0 into the second derivative. You'll see it's a positive. So therefore, function is concave up. So that's it. So we proved. Next one, we're going to use a trapezoidal rule to estimate the area under the curve. So we all know trapezoid rule is using this formula. I'm going to ask you to remember from A to B, so that's the initial A, or sometimes it's just x0, and this is xn. All right, so this is xn minus x0, so the last point, last x minus the first x. So then in the middle, we put a x1 to xn minus 1. So we're using sigma notation. But you need a twice of it because it's trapezium. So basically, trapezoid is using all those square boxes, or square, using the square straight line using trapezoid instead of using curve. All right, so let's estimate. So we're using the formula because we got two of them, symmetric, right, left, it's same. I'm using 2 in the front. So I'm going to substitute. So the last x is 1, the first x is 0. So you got x0, x5. In the middle, you got 4 sections. So we divide a curve into 4 sections. So that's why we use 4 trapezium. So then we put the first f0, x5, and plus 2 times by the middle. So fx1, so this is fx1, fx2, and fx3. Sorry, this should be 1, 2, 3, and 4 because of the 4 strips. My apologies, I got some issues. So the last should be n is 4. All right, so we're using graphics calculator. We get the answer is approximately 0.538. Now, then we will estimate, is it overestimated or underestimated? Now, using geometry, you're pretty straightforward. You straight away say it's because the curve is concave up. So therefore, those straight lines or above the curve, because it's a concave up. So therefore, this must be overestimated. So that's verify using another way, using integration. So we're using the integral. So we say, let's using the hard way, using algebraically, using calculus. So we said the area is twice of from 0, 1, and integrate 1 plus x squared with respect to x. Now, this is a little bit harder for method students to do this question because you haven't used the integration by parts. So I'm going to introduce this integration by parts formula. So if I have an integrate u dv equal to u times by v, then minus v and du. So let's say this is my u and that's my v. So therefore I have a u times by v, and then we copy v, so copy v, then differentiate u. So can you see when I differentiate u will be 1 plus x squared in the denominator because it's log, then times by 2x. So make me 2x squared. So I'll move 2 outside. So now I'm going to integrate this one. I'm going to use a partial fraction. I'm going to plus 1 and I'm going to minus 1. So become plus 1 or cancel the denominator, become 1 minus 1 over x squared. All right, so that's copy this first down, then we integrate it. 1 is x. Now this one integration is tangent inverse of x, tangent inverse x, inverse tangent x. So now we're going to make expanding bracket. So my answer should be, I'll take an x out because you got x, you got x. So I'll take an x out, so it'll be this minus 2 times by that. So then I'll plug in. Plug a 0, 1 into that. So I get 1 plug in. So you got log of 2 minus 2, then pi over 4. Then become pi over 2. So therefore, my answer will be 0.5278. So you can see my answer B is overestimated because my answer B is 0.538, but now it's the real is 0.52. So that's it. That's the answer for this question. It's a little bit hard, but it's a very good question. I hope you enjoyed it. If you do, please give us the thumbs up. I'll see you in the next video.